Welcome students to our next class, that is analysis and design of algorithms. So in the previous class we have seen the introduction to algorithms, definition and few basic concepts, and we have taken an example of GCD of two numbers, and we have seen how the same problem can be solved by using different algorithms. So in today's topic we will be discussing in detail about the fundamentals of algorithmic problem solving. Of course, this is one of the very important topic with respect to the examination. Now here, what do you mean by the fundamentals of algorithmic problem solving? That means in order to solve a particular problem using algorithms, that means you are going to write certain algorithms. Now we are supposed to follow certain steps. Now what are those steps we will be discussing in this particular concept. Now as you already know, algorithm means it is nothing but a procedure solutions to solve a particular problem. Now these things we have seen. Yes, now let's come to the fundamentals of algorithmic problem solving. Now this flowchart is very important. Now this diagram pictorially it tries to represent all the various steps what we are going to use in order to solve the following problem algorithmically. So that means it starts with understanding a problem. So you have to first understand the problem, just like solving any problem in any field. What we try to do first is we try to analyze before analyzing, so problem definition, right? Problem statement, understand the problem. Then there are four important parameters which we are supposed to decide on or discuss on. So one is computational means, so exact versus approximate solution, the data structures, algorithmic design techniques. So one by one we will be discussing in detail. So this is the second stage we can try to understand, and the third stage is designing an algorithm. Once you have discussed on all these things, now the next step is you are going to design an algorithm. So then prove the correctness, so analyze the algorithm, and the final stage is coding the algorithm. That means convert your algorithm into a particular problem. So now let us start discussing one by one in detail. So the first step, understanding the problem. Now when you want to go for solving a problem, that is giving the problem statement, now we have to understand the problem. Now when we say that understanding a problem, now what are the important points to be considered here? So the first is, before designing an algorithm, understand completely the given problem, the problem definition. So as a the analyst or as a programmer, you are going to design an algorithm. First and foremost thing what you are supposed to do is try to read the problem carefully, try to understand what is the particular problem, try to ask questions to yourself so that many of the doubts can be solved on your own, and try to take some simple examples, small examples, and try to see now how you are going to solve that particular problem. Now when you have clearly understood the definition of the problem, and as you know that already in the previous section we have discussed that whenever we are talking about an algorithm, now there are some important characteristics. There we have discussed input, because any algorithm, when you are going to consider, every algorithm has got a definite input. That means there should be some input, either zero input or certain input should be there. So an input to an algorithm, it specifies an instance of the problem, right? It is a small instance of the problem, whatever the input you are going to give. Now it is very important to specify exactly the range of instances the algorithm needs to handle. That means now what is the range, what type of input you are going to give. Like say for example, if your problem is to addition of two numbers, so what is the input is required? So obviously, since this example is very simple, so addition of two numbers means two numbers are required for us. But when you are saying that you need two numbers in order to add to write an algorithm, so what type of numbers, right? Now what type of numbers you are going to give as an input, how many numbers? So we have to exactly decide on the range of instances, so what the algorithm requires. Now if you try to fail in identifying what is the input, what is the type of input, how many inputs are required, then obviously the algorithm will clash, and we can see it goes to infinite loop, or it may not give you the accurate answers. So we have to remember that a correct algorithm is not one which works most of the time, but one that works correctly for all legitimate input. Now this is very important, all legitimate input. That means input should be correct. Every time we cannot say that I have written a correct program, but the system is not working, the software is not working, we are not going to get the output. But you should be very clear that are you giving the correct input? See, your problem or the program of addition of two numbers may be correct, but input what you are going to give is very, very important. Have you given correct input? So that's what we mean, that legitimate input. You have to remember that for all legitimate input in a given particular time, the algorithm should work exactly and give the result. Then we can say that algorithm is correct. So that is the first important step. Understand the problem, what is the input, the legitimate input, the range of the input. That is the first step. Now second step, we said that, so if you go back to that diagram or the flow chart, now here we have said in the second box or in the second stage, now we have four important parameters to be discussed, or we are going to consider these things. So now what are these four? We will try to look one by one. The first one is asserting the capability of computational device. So what does this mean? Asserting the capabilities of computational device means for what type of a device we are writing the algorithm, or in order to solve this problem, the problem what you are going to consider, that particular problem is solved by using which device. And as you know that what all the devices right now we are using, that is our desktop maybe or a laptop, what you are using. So these devices we call it as a von Neumann architecture. That means the architecture on which these devices is built. That is, you have input, you have output, you have system unit. Now in that you have got primary memory, secondary memory, ROM, RAM. This block diagram you might have studied in your elementary class. So this architecture we call it as von Neumann architecture. And one of the fundamental basics of this von Neumann architecture is how this RAM is going to work, how the system is going to work. Now it executes one by one instructions. It takes one instruction, executes it. After executing the first instruction, it goes to the second instruction. So we call it a sequential processing, right? So algorithms written for such a machines, we call it a sequential algorithm. Okay, so you might have studied Java or other programming languages where we use multi-threading concept, etc. With respect to the operating system. Now that concept is different. Even though at an user and an OS level you say that you have got concept of multi-threading where you try to execute in a more number of programs or instructions simultaneously in terms of thread. But if you go back to your system level, that is in terms of ROM and RAM, so still they execute only one instructions, one after the other. It takes in a sequential manner. So we call such a type of a machines, or the algorithms written for such a type of machine, a sequential algorithm. Okay, so I think this is very clear. Next we have another type of an algorithm which are called as parallel algorithm. Like say for example, when you are talking of supercomputers, our normal system has got only one CPU. So whatever we are writing, it is sequential. Now when you are talking of supercomputers or in these type of machine where we have got more than one processor, there are more than one RAMs, there are hundreds together RAMs are been coupled, and we are calling it as a supercomputer. Now there the concept entirely changes, the OS changes, the algorithm changes, the way we are writing the algorithm is going to change. Such a type of algorithms we call it as parallel algorithm. Now anyhow, in our course, in this particular course, we are just considering only sequential algorithms. So we are not writing an algorithm for a parallel system, parallel computing or parallel systems where we have multiple RAMs are available. So this is ruled off the second point, but still we have to remember that okay, we are using which type of computational device. We are using a device which follows the von Neumann architecture. In such a type of an architecture, the sequential processing is been done. So execution is been done in a sequential manner. So this is the first point which you are going to consider. Okay, the second one is that choosing between exact and approximation solution. And this is also very, very important. Now when you want to solve a particular problem, Now you should know what type of a solution we are going to get. Now generally this solution we classify it as exact solution or an approximate solution. What type of answers you are going to get. So solving the problem exactly, now we call that as an exact algorithm or an approximation algorithm. That means where the solutions are approximated. That means you don't have an exact solution. Like say for example, the problem cannot be solved exactly like say square root. If you consider square root, when you are going to find a square root, so after decimal point there is so many digits, there is infinite digits, or say for example pi value 22/7. Now so there what happens is there is no stop, right? So what we are going to do is we round off after 2 decimal digit or 3 decimal digit exactly. Those such a type of solutions are you going to expect when solving a particular problem. That's what we are going to decide. So the solution your problem which you are going to consider, is it an approximation, or is the answer like going to be an approximate where you want to round off to after 2 decimal digit or 3 decimal digit or 4 decimal digit, depending upon to what level of accuracy you need, or the answer to this is exact. Exact means like say for example addition of 2 numbers. When you add 2 numbers you are going to get a third number. That is an exact. You don't say that 2 plus 3 is equal to 5. We don't say 5.0100 like that. So we have an exact solutions is available. So now this is another point which you are going to understand and decide that the output or the solution to your particular algorithm is it an exact or is it an approximation. So this is the second point which you are supposed to discuss. The third one is the data structure, appropriate data structure. Now what are the data structure is required for us, right? Now already you have studied the data structure in your previous semesters. Now when you want to solve a problem, now what type of data structure you need to select, right? So you have studied so many data structure, primitive data structure, secondary data structure, and the primitive int, float, character, right, bytes, etc. And under secondary you have studied arrays, list, queues, stack, tree, graph, etc. You have so many data structure in front of you. Now when a problem is given, which is the data structure need to be selected? That's the question from which you are supposed to answer. So you should know that, okay, for addition of 2 numbers I need to take int as a data structure, or I should take a linked list as a data structure. Now it is left to the programmer and it is left to the problem what type of a data structure is required for us. So this is the point we are supposed to discuss, that is which is the appropriate data structure required for us. And in the last one, that is algorithmic design technique. So once you have selected what is the algorithm, so then you should know algorithm design technique. So what do you mean by algorithmic design technique? If you look into the definition, now the algorithmic design technique, or you can call it as a strategy or a paradigm, it is a general approach to solving problems algorithmically that is applicable to varieties of problems from different areas of computing. Now what does this means? That now in order to solve the problem algorithmically, we have different strategies. We can apply different strategies, or we can in another simple term we can say that we have different methods to solve that particular problem. So now those are called as design techniques. So you have so many design techniques. So later in our course we will be discussing one design technique. Like say for example, you have a design technique called as brute force, or divide and conquer, decrease and conquer, transfer and conquer, etc. There are so many techniques are there for us. Now when a problem is there, now you should decide that, okay, should I use brute force technique, should I use divide and conquer technique, or decrease and conquer technique, or a transfer and conquer technique. So which one is required for me, which technique I have to use in order to solve this particular problem. So these are the 4 important points. Now what you are supposed to discuss. So now if we go back to our the flow chart, you can see that. So what we have seen, first understand the problem, so then you have to decide on computational means, that means which is the type of a device, then exact versus approximation solution, then discuss about the data structures, so then which design technique you are going to use, what is our design technique. So once you have completed these two stages, so the next stage is you have to design the algorithm. So how we are going to design an algorithm? So how you are going to write an algorithm? So generally you have got by using pseudocodes. So as we have discussed in our introduction class, nothing but a mixture of natural language and programming languages, and we use some mathematical notations or symbols also, or you can go with a flowchart, that is a diagramical way or pictorial way of representing an algorithm. We call it as a flowchart. You can select any one method and you try to design an algorithm. Once an algorithm is been designed, the next very crucial step is you have to check the correctness, proving an algorithm correctness. Now this is a very crucial and very important, simultaneously very complicated task also. So in the next unit we will start discussing about this, proving the correctness. Now what do you mean by proving the correctness? Right? So once you have got an algorithm, like say addition of two numbers, you came up with an algorithm. Now you should prove that whether this algorithm, does it works for all type of two numbers, or whether it is going to work only for two positive numbers, that is it is giving addition of only two positive numbers, or it will give the result if one number is positive, one number is negative, or both the numbers are negative, or one integer, one decimal, like this, etc. Right? For all. So what you are supposed to do, algorithm, proving the algorithm's correctiveness means we have to prove that the algorithm yields a required result for every legitimate input in a finite amount of time within a given time frame. So if your input is correct, if your input is legitimate, then your algorithm should give you a proper result. So that is what it says, proving in algorithms corrective. Now if your algorithm, if this output of your algorithm is approximate algorithm, that means if you know that your results is not exact, it is approximation, so then we should know that to what level of accuracy. So right, the error factor what you are going to consider. After 3 decimal place you want to stop your program, or after 10 decimal place you want to stop your program. So you have to discuss those things. So once you prove the correctness of your algorithm, so next comes the analyzing an algorithm, right? So this is also very important. So this course itself says, the definition of the course or the title of the course itself says that design and analysis. So now you are going to do the analysis of your algorithm. Now how do you do the analysis of your algorithm? Already we have seen that when you want to look into the analysis, so there are 3 things. So one is efficiency. You are going to check that whether your algorithm is efficient. On what parameter? Basically 2 things. One is time efficiency, indicates how fast the algorithm runs, or it's also called as time complexity. You have to calculate the time complexity and see that yes, my algorithm is working fast. The second one is called as the space efficiency. It indicates how much extra memory the algorithm needs, right? Extra. So normally when you are going to write an algorithm and convert it to a coding, there are certain memories which is required. Apart from that, is your algorithm unnecessarily using or extra memories, no, which is also called as space complexity. So in order to analyze the efficiency of your algorithm, so either you will be looking into the time complexity or time efficiency and space efficiency. This is the first thing which you are supposed to do when you are going for analysis of an algorithm. The second one is the simplicity. Again, it's very straightforward that whatever the algorithms you are going to write, it should be very simple. So it should be so simple that anybody can understand, right? So today if I write one algorithm, if I write that algorithm too complicated and give to you to do the program that or convert that particular algorithm, if you are unable to understand that algorithm, then nobody will tell that I am a good programmer or I am not a good researcher or trying to give problems in a particular manner, because it is not simple. Always you have to remember that whatever the algorithms or the programs you are going to write, it should be as simple as possible. right? This is the second thing. The third one is generality. That means your algorithm should be as general as possible. So once you write a program or once you design an algorithm for addition of two numbers, now the algorithm should work for all legitimate inputs. So it should be as general as possible. You cannot say that I have written a program for addition of two numbers but giving a condition to users that give only two positive number. My program won't work if you give one negative number, or my program will stop in between if you give one decimal number. No. If you just say that you have written a program for addition of two numbers, means finish. Whatever may be the two numbers, the program should give you the result. So it should be general. So these are the three important things which you are going to do for analyzing an algorithm. And of course the last stage is coding the algorithm. So once you have done with all those things, or the previous steps what you have just now listened, now you are supposed to code the algorithm. That means convert your algorithm into the program, whatever may be the programming language you have selected, either C or C++, etc. You convert it, write the coding, again test it, debug it, run it, you know all these steps. So these are the steps which have been followed and which we call it as fundamentals of algorithmic problem solving. So as I told, it's a very important question with respect to the examination also. You have to start writing the flow chart and try to explain every important points in the each stages. So this is the main topic which we wanted to cover in this particular class, that is fundamentals of algorithmic problem solving. So next we'll go to another small topic called as important problem types. Now what are these problem types? That means what all the areas in which the problems we are going to pick in this course and try to solve those particular problems. So these are some of the important problem types. That is, we have some of the sorting, so we have searching, we have string processing, graph problems, combinatorial problems, geometric problems, as well as the numeric problems. So what are the important tasks? Because sometimes in the examination for a short notes or 4 marks, generally they ask the problem types. So let us start with the sorting. Now you know that what is a sorting process. So the sorting problem, it is nothing but you are going to rearrange the elements or items in a given list in some order, right? In some order, either it can be an ascending order or it can be a descending order. Only thing, you are going to rearrange. So you have got a list or an array, in that you have some items are there, you arrange these items in some order. The order can be defined as either it can be an ascending order or it can be descending order. So this problem we call it as the sorting problem. So later in our course, now we will be looking into the various type of sorting algorithms. We will be trying to design and try to analyze that particular algorithm. And where this sorting is very important, some of the applications like sorting list of numbers or characters from an alphabet, like say you take one alphabet and you are going to sort that character strings, you want to sort the strings, or say you are going to record similar all the student details based on the USN number. So if you want to record all the student details based on USN number, you have to sort that USN number. In sorting comes libraries about their holding, right? There are so many applications where the sorting becomes very important. So sorting is one of the problem area. Now similarly the searching. Now searching problem, it once again, as you know, it deals with finding a given value, or what we call you are going to search one particular key. So you have got some set of numbers or items. Now in that particular items, now you want to search one particular item or one key, right? We call that as a searching problem. So you can even see that lot of applications can be given for the searching problems also. The third problem type is the string processing. So string processing, so as you know, a string is nothing but a sequence of characters. So in one by one or individual characters, we try to group it and we call it as a word, right? In English we call it as a word. So A, B, C, D, etc. up to Z is alphabets. When you combine these alphabets, we get a meaningful word. Similarly here, so we say we define a string. String is nothing but a sequence of characters. right? String processing. Now you are going to process that particular string. So we have so many applications, so many examples when we go for string processing. So like a lot of examples you might have written in your previous undergraduate programs. So like strings, it can be a text strings where will be having letters, numbers, special characters, everything, or it can be only the alphabets, or it can be the numbers, or it can be the bit string, so it has only zeros and ones, right? So you can deal with different number of strings, and so many applications are also there. Now in our course we'll be considering one type of an example of string processing, which is called a string matching problem. So string matching problem is finding a substring in a given text. So you have got a big text. In that text you want to find a small word or substring. We'll be discussing that example also in our later on sessions. So string processing. Now similarly we have got some type of a problems which are called as the graph problems. So what do you mean by a graph problems? Now later we'll see what do you mean by a graph. A graph is nothing but it is a tuple which consists of points and edges, right? Edges are also called as vertices. We can say that a graph is a collection of points. It is a collection of points called as vertices. So each point is called as a vertices, and these vertices are connected by lines or edges. So we can say that a graph is nothing but a tuple. G is equal to, we can write it as a tuple which consists of V comma E. So what is V here? V is set of all vertices, E is the set of all edges. So each vertices are connected with the edges. So later we will be discussing more about these graphs and all. So we are going to consider some of the problems in discussion, like say traversing a particular graph or finding the shortest path, topological sorting. Now these are all the few examples which we will be discussing whenever we are considering the graph problems. And the next type of problems are called as combinatorial problems. So that means it is a combination of permutation and combination. So we have got permutations, we have got combinations. It is a mixture of permutation and combinations problems. So problems like say that asks to find a combinatorial object such as permutation, a combination, or a subset problem, right? Now these type of problems also we will be trying to discuss as well, or we try to pick some problems like say finding the subset or finding the permutation. These type of problems we will be considering and discussing. Now another important problem area in algorithms is called as geometric problems. We have some of the geometric problems like say convexal problem. So we are going to find the smallest convex polygon, right? And we have got closest pair problem. So these are all the problems where the geometric objects, where we deal with the points, lines, polygons. So these type of problems we call it as geometric problems. So next we have got numerical problems. So numerical problems now it's another branch of, and we can say the mathematics where lot of applications have been built, like say linear equations. So solving some of the linear equations, integrals, now all these type of areas we call it as a numerical problem. So these are the some of the problems areas. Now what we will be discussing, that means in each areas we will be picking some problem and try to solve those problems, try to understand how these problems are being designed and how these problems are being analyzed. Because as we have seen that the only important thing what we are going to do in our particular course is that how to design a problem, that is how to do the analysis. So when you are doing the analysis for all the examples, now we will be considering two important things. What are those? So one is called as the time complexity and the space complexity, as we have discussed. Now in these two, time and space complexity, now we see that or we give more concentration only to the time complexity, because we have considered that space memory is very cheaply available in the market, so we need not worry much about our memory, but time how fast the algorithm is executing. So basically we will be working only on the time complexity. So you have got analysis, so you will be doing the analysis on time complexity, and when you want to design this algorithm, that is how you are going to solve these algorithms, maybe you have different design techniques, maybe you have got different design techniques are available. So one by one design techniques we will be discussing. So this was the important topics of today's class. So in the next class, now we will go into the actual fundamentals of analysis of our algorithm. So when you are going to define, and when you say that is your algorithm efficient, on what basis you are going to tell your algorithm efficiency. So we look into the analysis of our algorithm efficiency. So that means we will be trying to understand what is the time complexity, how this time complexity are being defined. So these things we will be discussing in our next class, which is very important. Thank you.